Hi guys, and welcome back to another lesson in Algebra 1. Today's lesson is going to be using Unit 3, Lesson 4. It is multiple representations of functions. It turns out that we can evaluate a function in a graph form as a mapping, a data table, or equation. And so we can end up finding the output values, or we could find the input values depending on what we are given. So let's remind ourselves about what a function is. So a function is, just this little fancy style equation. It's got this kind of weird thing where it says like f of x. And so that's how we know it's written in function notation. Well, let's go and start, kind of color coding some stuff here. So the output, remember the output is this side. It's the f of x, okay? And so let's see, let's write some notes about that. So it's going to be the number outside the parentheses. So you'll see something written along the lines like this, where you'll see, f of x equals 10. Okay, so what this means is that, 10 is the output. And what you would do is, let's see, we can put a little bullet there. We can plug in 10 for the f of x. And so when we plug in the 10, it ends up looking like this. We would end up writing 10 equals 3x plus 2. We would just simply replace that f of x with this 10. Okay, so that's what that looks like. Now, we can address the other side. The other side is your input. So let's get a different color here. We got an input. It's going to be this x. This is also the number that is inside the parentheses. Okay, so when we write this, it's the number inside the parentheses. And so in this case, it's 8. So 8 is the input. And what we would do is we would plug in 8 for x. So in this particular function that we have, again, if I wrote it again down here just to kind of, give myself a little bit of room since I wrote all the other stuff there, I would plug in the 8 right here. That's where it would go. Go right here in this spot. So we could replace it and it would be like f of x equals 3 times 8 plus 2. Okay, that is the equation way of writing things, but what if you're given another representation? What if you've got a graph? Well, we need to think about what this means when we've got this graph format. So if we're given this, what is our inputs and outputs, and what do we use when we've got this guy and we've got this guy, and it looks all foreign to us? Well, the good news is that you have this knowledge from, equations before now. We've just gone and fancied it up a little bit with function notation. So the number that is right here in this, that's our x value. So we can come over here. So if my x is 3, we come over here to 3, and then I'm going to go get the point. So the point is right here. Well, it wants to find the value of this. Okay, so the value of f of 3. Well, in this case, all this is asking for is it's asking for the y. That's all it is. It's just asking for it fancy style. So we come over here and we read what the y is, and we can see our y is 1. So we can write f of 3 equals 1. Okay, if we had written this not in function notation, we might write something like y equals 1, but because we're writing it fancy style, we're doing it this way. All right, now what if they ask it the other way and they ask for f of x is -4? What are we going to do? Well, remember, when we see it in this format, this is the output. This is the y. Okay, it's the output. So what does that mean? Let's go find where we see -4. So we see -4 here. We're going to read across until we figure out where we see it. So it's got a point right here. And then we're going to find its coordinating x value, which its x value is -5. So when it says find the value of x, we're going to write it as x equals -5. So all you're doing is finding the other half of the coordinate point. It's just written in function notation. Okay, the concept isn't really hard, but when they put it in that fancy style notation, it can throw you. Okay, so let's look at this one here. So we've got this, it's got 0 here. So what is this? If it is in the parentheses, this is going to be my x. So I'm going to look at my x's. Here's my x's. I'm going to look over here and I'm going to see where my 0 is. And here's my 0. Okay. And so when I see my 0, I'm just going to look across the side here and this is going to be my answer. So my h of x, this is like the same thing as y. Okay. If we graph this on a graph, the coordinate point would be 0, 2. So the old way we might have written this is, y equals 2 when x is 0. But we're going to write this fancy style. So we're going to write h of 0 equals 2. All right. Let's look at this guy. And again, if I'm going too fast, by the way, just go ahead and pause it. Because, of course, I'm recording this ahead of time, so I don't have any students. So, if I get going on a roll, which I do, then, pause it. Alrighty, so this is my y value. When you see it written like this, where the number is outside the parentheses, it's the y value. So we're going to come over here and I see my y value is this. We can even color code that a little bit there. This is my y value. And so to find the coordinating x value, we're just going to read across here and it's -3. So we're going to write this, x equals -3. Draw a box. Okay, so that's how it looks when it's in graph form using function notation and when it's in data table form. But what if it's in a mapping form? So remember, our mapping shows all the possible points. So this is a mapping. It looks like this bad boy. It shows you all the x values over here and it shows you all the possible y values. Well, if y is replaced f of x, we can color code it this way. This is my f of x side, and this is my x side. All right, so when we see a number in the parentheses, that is an x value. Okay, so this, we're going to come over here. We find our 6. We're going to read and go find the coordinating y. And so that's 1. We could write it y is 1, but it's asking for it in the function notation, so we can just write f of 6 equals 1. Okay, let's look at it the other way. Let's say that we have this whole thing, f of x equals 5. Okay, so remember, this is just the y value. Okay, and fortunately it says f of x equals 5, and we see this is written f of x. We know that we're going to go get this number right here. We're going to read back across, and we see that 3 is its answer. So the x is going to equal 3. Okay, so that's what it looks like when we have we have a graph and we have a data table and we have a mapping. But it can get a little bit hairier when we are dealing with word problems. So let's read all this carefully and see what we get. Okay, so we have a designer charges a flat fee of $75 per consultation and then $50 per hour. So when you read this like a flat fee, this sounds like a y-intercept. Okay, that's kind of a dead giveaway for a y-intercept. And when you see this 50 per hour, this sounds like a slope. And so, indeed, they wrote the function out for us, which was really nice. They got d of x equals 50x plus 75. Well, we need to just kind of take a second and make sure we know what these different parts mean. So, the flat fee was 75. So this is my flat fee. That's my y-intercept, and it's a flat fee. This is my slope. This is how much they make per hour. So this is money per hour. And so this X here, this is going to be the number of hours. Okay, so however much they're working is going to be X. And then the D of X kind of makes sense that if it's like money per hour times number of hours worked plus their flat fee, this guy here is going to be earnings. Okay, so that's what all the little components mean. So if we have this situation where we've got 3 here, and this is in the middle of my parenthesis, so we know that when it's like the number in the middle of the parentheses, that's my X value. Okay, let's just take a moment and remind ourselves what we said was our X and what we said was our Y. So I'm just going to define my variables real fast. I'm going to define it as a let statement. The reason that I do this is it helps to keep my brain straight about what each component means. Okay, so my X is going to be my number of hours. So that's my number of hours worked. And then my Y, which really, is going to be this D of X, right? Like that's the fancy style way that it's written, is going to be my earnings. Okay, so what does this mean? If my X is 3, that means that this designer worked 3 hours. Okay, so that's the first thing that it means. The second thing is like it said to find the value of D of 3. Okay, so we're going to plug that 3 into this function. So let's go ahead and work that out real fast. So that other part of this is my function. We got D of X equals 50 times X plus 75. I am going to plug that 3 in right there for that X because we're working 3 hours and we're making $50 per hour, which is awesome. So let's figure out what that is. So 50 times 3 plus 75. 50 times 3 is 150 plus 75. We can kind of just keep writing over here. So my D, when it's 3, we're earning $225. Okay, so what this means is that they earned $225 in 3 hours of work. Okay, it's a good gig if you can get it, huh? More than a teacher makes. There you go. Alrighty, let's look at it another way. What if they gave us this situation where they said the D of X is 475? What does this mean? Okay, so equations don't exist in isolation. They mean things. What does it mean to have that here? Well, remember we said D of X was earnings, right? That's what we said. That's why we defined our variables up here because it helps us keep it straight. So if this is essentially saying earnings equal 475. They just wrote it as d of x. So what does this number mean? You know, this means, whoops, well, let's see. I made a little error there writing. They, here we can go ahead and call that one. They earned 475. Okay. Now, there's a second part to this. It's asking, find the value of this. Okay. So if my d of x equals 475, I can rewrite the equation. I'm going to go ahead and write this over here. I'm going to rewrite this function. D of x equals 50x plus 75. I just got it from up here. It's the same one that we did last time in the last problem. But for my 475, I'm going to write it right here. Okay, it replaces d of x equals 50x plus 75. So I'm going to do a little bit of math now. This cancels. 475 minus 75 is going to give me 400. Okay, we can divide by 50. We divide by 50, and we end up with x equals 8. Well, what is the 8? Okay, like what is this? This is not just a random number. This is a number that means something. Well, remember, we defined what x was, and this is what we defined it as. Let me go kind of highlight this real fast. We defined our x up here as number of hours. Okay, so that means that they earned 475, you know, and they worked 8 hours. Okay, so because they worked 8 hours, they earned $475. That's what that means. Alrighty, so let's go ahead and look at this next example here. So we're going to think about this rock. So Juan has a rock. And this rock is doing fun things. Okay, so let me go ahead and draw this. We've got a rock here. It's being thrown off a cliff. So this is my interpretation of a rock. It's going flying up here, and then it's going to eventually land back down on the ground. Okay, so that's our path that we are on. We're on this path here. The rock's going, okay, that's what our graph is showing us. And so it says Juan throws a rock off a cliff. So then it makes a lot of sense that, you know, they're over here, you know, they're some amount of feet off the ground. So they're on a cliff. This is my cliff. And this is, you know, it turns out that's like 10 feet off the ground. So the height of the rock can be written as function h of t, where h of t is the height in feet and t is the time in seconds. I am just going to write down what that means again. Okay, I'm going to make myself a let statement. Why do I write this down? Because I'm trying to organize my thoughts and make sure that I know what everything means. So my t is time, and that's going to be measured in seconds. And then my h of t, that is going to be height, and that's measured in feet. Okay, we're going to go get these numbers off the graph. This here, the 0, that, remember, this would be like my x value. Okay, and you're like, but we didn't write x over here. That's because they gave us t. If we look down here on our x side, we see time. Let me scroll down just a little bit so it's not, you know, so hidden. So our time is on our x, okay? And so we're wondering what's happening at 0 seconds. That's what that's asking, is what's happening at 0 seconds. So we come over here at 0 seconds and we can see that this is the first instance when the rock is thrown and it is 10 feet up in the air. So what does it represent? This means uh, when the rock is first thrown, we can see that it is 10 feet high, okay, on the cliff. Okay, it's shown here as a graph. This, we can see that that is 10 feet off the ground. That's where it's starting. All right, so what does this h of 0.5 mean? Well, this right here, again, this is going to be another x value or another, x variable. This is time. We set it over here. It's time. So we're looking at, the time equals 0.5 seconds. So we come over here and we see my time is 0.5 seconds. Well, what's happening right here with this rock? We look at it and we're like, you know what? I bet it's hitting the ground. And so h of 0.05 means that is the time the rock hit the ground. Okay. We can tell from the graph that that's what it was doing. And if we come over here and we see this 0.5 and we read over here, we can see that that is 0, right? So the height off the ground was 0 right there. All right, there's another landmark. What does this landmark mean? So it says, what is the value of h is 0.18? What is that? Okay, so what does this mean? I guess I didn't mean to hit my pencil there. Let's come over here. So this is 0.8 about here, and we can go up and we can read this. And we look at this and we're like, what's happening right here? Okay. And it looks like this is the max height, the maximum height that rock went up in the air before it started falling back down. And we can even tell by reading the graph, the maximum height looks like it might be about 23 feet. Okay. So what does age 18 mean? So this is going to be, the maximum height of the rock. And that is, well, let me erase that period. Here we go. We'll erase that period. And I can erase this here because that was a little messy. Okay, so the maximum height, I should probably fix that. See, this is what happens when you start erasing and you kind of got a lot of stuff here. You kind of then it just gets, you keep erasing stuff. It gets worse. Okay, so the maximum height of the rock is about 23 feet high. And the other thing that we can tell, it hit that at 0.18 seconds. Okay, so it took 0.18 seconds for it to hit its maximum height. So each one of these numbers tell us something. And so it's taking the time to reading the graph or reading the equation and trying to think, okay, what do these numbers actually mean? I hope that helps, guys. Until next time, bye.